Welcome you all for the lecture session on the subject of engineering graphics having in subject code of 18 EGDL 15 or 25. So in the previous session under the solids we have begun with a special type of a problem where we have considered a square pyramid that was resting on one of its slant edge and we have completed the problem. In today's session, let us continue with a similar type of problem, but the type of solids that we are referring is a pentagon. So the pentagonal pyramid will be having 5 sides, each is indicated as a base, and we have the slant edges, slant triangular faces, and the apex point connecting all the triangular faces or the slant edges. All the fundamentals that you have already learned with respect to the introduction of solids, and you also know the construction of a pentagon since you have already done in planes as well as in the solids also. So in today's session, let us quickly move on with the problem. Let us see the problem statement. It states that a pentagonal pyramid 25 millimeter sides of base. Each side of the base is of 25 millimeter. A pentagon will have 5 sides and each side of the base is having 25 millimeter and 50 millimeter axis length. So it is the axis length of the particular pentagonal pyramid is of 50 millimeter. Rests on HP on one of its slant edges. So this becomes very important for us. It has to rest, this pentagonal pyramid has to rest on one of its slant edges. It has to rest on one of its slant edges. If they have mentioned on one of the triangular faces rather than the slant edge, if they asked in order to rest on the triangular faces, you are supposed to rest like this. Basically a corner or the edge condition in the previous cases that you used to solve. Here they are specifically mentioning we are supposed to rest the pentagonal pyramid on one of the slant edges, a corner condition of a pentagon. So this is resting on the slant edge. Then draw the projections of the pyramid when the axis is inclined to VP at an angle of 45 degree. This statement is very important. Here they are not mentioning it is appears to be inclined at an angle of 45 degree, where in that case we need not to calculate the beta angle, whereas here they are mentioning that the axis itself is inclined at an angle of 45 degree. So we are supposed to calculate the angle of beta in the final position. In order to complete the final position, we are supposed to calculate the angle of beta in this particular problem. So let us begin with the construction of the particular problem based on the conditions that they have given. As usual, the first step is to draw the XY line and mark VP and HP. So we have identified, we have drawn XY line, the X and the Y line, and we are also supposed to represent the VP HP condition, the vertical plane and the horizontal plane. So let us begin with the construction of the pentagonal pyramid, and the pentagonal pyramid is having a base side of 25 millimeter. So first, as usual, we know we are supposed to rest that on the slant edge condition. So be careful with respect to that. So first draw one of the base, next one of the side basically. Next, you know that angle is of 72 degree in order to construct the other two sides. For that, particularly draw the construction, take the angle and complete the construction of the pentagon, ensuring that it is resting on the slant edge condition. Once we are done with the 3 sides, in order to complete, you can go with the arc method in order to identify the corner of the pentagon or the other 2 sides of the pentagon. Cut an arc from the point from both ends. So by this method we can complete the construction of a pentagon resting on the slant edge. Resting on the slant edge. So the first most thing that we are supposed to do is to name the corners. So I am going to call it as A, B, C, D and E. Next, it becomes important to identify the points which are visible and not. So we are resting the pentagonal pyramid on one of its slant edges, and when I look from the top, I can clearly see all the sides of the pentagon. Along with that, I can also see the slant edges, the 3 slant edges when I look from the front view. But as of now, since we are writing only the first position, let us think only of that from the top view. I can see all the base edges. So let us tick that particular part and then we'll move further. So C to D is clearly visible, and again E to D is clearly visible. From C to B is clearly visible, and B to A visible, and from E to A is also completely visible. All the sides are completely visible. But in the previous case of a square, all the diagonals that were meeting were crossing each other. But here it is not the same condition. We are supposed to find out the axis where they are going to meet. All the corners are going to meet at a common point. We are supposed to identify that. Along with that, we can clearly see the sides or the slant edges. So only the portion up to the axis it is clearly visible. We are supposed to make that dark, and the other thing will be in the light line. So first identify the midpoint of this particular condition. So how to do that? Draw thin lines from the corners to the from all the corners basically. So we have got the point where the axis is going to begin, or the point of the axis, but here the portions that are visible becomes very important. From E to O or O1 it is completely visible. From A to O, similarly from B to O, C to O, and from D to O. So these portions are completely visible from the top. So we have forgotten to name here. So this particular point will become for us O of O1. Either you can retain these thin lines or you can wipe it off so that it is clearly visible for us. Now let us begin with the further step, which is in order to draw the projection lines. Draw the projection lines up to xy first, up to xy. Similarly, from the corners of B and E, it's a common line, both. From A corner, from C to D it is a single line, projection line, and again from B to E and from A. From the O1 we are supposed to draw the axis projection line. First I will draw up to the xy line only. Now we are supposed to carefully draw the axis length. Here they have specified the axis length is of 50 millimeter. So first we are supposed to draw the axis. In the previous case of a square, one of the edges were overlapping the axis line. So we directly drawn a thick line, whereas here it is not happening. So we are supposed to identify the axis line. We are supposed to draw the axis line, which is a chain link line. So just draw the axis line for about 50 millimeter. They are clearly mentioning it is of 50 millimeter axis length. So draw that 50 millimeter axis length, and we have forgotten to dimension one of the sides. It becomes very important. So don't forget, in any of the problem, show any one of the side dimension. So this particular side is of 25 millimeter. It should be a filled arrow. Each side is of 25 millimeter, and we are supposed to show the axis length as well. Axis length in the front view, it is of 50 millimeter. It is of 50 millimeter. Now, if I consider the pentagonal pyramid and if I rest it on one of the slant edge, you can clearly see that this slant edge is clearly visible from the front view, even from this end and this end. So all the corners that are appearing from the front position, that is connecting for the apex, are clearly visible. So we are supposed to just join those edges completely with the help of a thick line. So from the C dash to D dash, it is completely visible. From A dash also, it is, this slant edge is visible. From again B dash to E dash also completely visible, along with the base edge. We are supposed to name the corners, that is C dash is visible, C dash of D dash. Here O dash is my apex, it is O1 dash. Here it is B dash of E dash, and from here it is A dash. Now what is the condition they are specifying? They are specifying that it is completely resting on one of its slant edges. Either you can take from this particular slant edge, or from you are supposed to take from this particular slant edge itself, that is from O dash to A dash. In order to do that, what we are supposed to do? First, identify a point of A dash. Let us take this itself as the reference, because we are supposed to entirely rotate this slant edge onto the XY line based on the condition that they are given in the problem, where they are stating that rest on HP on one of its slant edges. So the slant edge is O dash of A dash, and we are supposed to completely rest it on the XY line. How to do that? With the help of an arc method, we can easily complete the process. I have identified the point A dash. The next point we are supposed to identify is the O dash, that is the apex point, O dash. Then I am supposed to identify the point of C dash and D dash from the A dash. From O dash, again we are supposed to identify the C dash and D dash point. So where the arc meets, that point will be my C dash and D dash. So let us name it in order to avoid the confusion. My A dash is here, O dash, and this particular point will become C dash of D dash. I am just transferring the first position into completely on the XY based on the condition that they have mentioned. So it is thick line from O dash to A dash. Again from C dash of D dash to A dash. From O dash to C dash of D dash. Now have we transferred all the points? No, we have not transferred all the points. We are still left out with 2 more points to be transferred. Either we can measure from A dash to B dash, or from C dash of D dash to D dash. From A dash to B dash of E dash, I have marked a point. Again from O1 dash to A dash, again from O1 dash to A dash. So identify the point. So this point will be my O1 dash and this will be my B1 dash of E dash, sorry, B dash of E dash. Now complete the process. We are supposed to connect from O dash to the point. Similarly from O dash to O1 dash, it's an axis line. It's an axis line. Now we have completely followed the condition that I mentioned. We have rested the entire slant edge on the HP. So what is the next step? We are supposed to complete the second position. How to do that? Draw the projection lines from both here and here. So meeting points will be the respective corners. So from A dash I will begin. From A dash I will begin. Draw the thin line, the projection lines. Don't extend the lines further. Let the points be on. It becomes easier for you to name also. So this particular point is my A. Similarly, I have B dash, E dash to B and E. I am drawing the projection lines with the help of a thin line. You are supposed to transfer the lines. Similarly, from O1 dash up to the midpoint, that is extension of an EA basically. And again we have from C dash to D dash, C dash of D dash. Again from here, from C again from the point of D, so only thing that is left out is from O dash, it is at the center. We have successfully drawn all the projection lines from the ends or the corners of A, B dash of E dash, O1 dash, C dash of D dash and the O dash. Similarly from the corners of E, D, A, C and B. Let us identify the points. So A and A dash, so this point will become my A. From B, C to C dash, the point of C. Similarly from D to D dash. Similarly from the point of E to the point of E. O1 dash, that is indicating as O1. Similarly the O dash, sorry, there it is O. Now we have successfully transferred all the points or the projection lines. What is the rule that we are supposed to apply? There are certain conditions that we know. The first condition is such that all the boundary or the edge or the faces are clearly visible. Which are all the boundary edges or the faces? A to E is one side, A to B, and from O to B and E to O. That is completely visible according to the rules. So first make that happen, that is the condition 1. From E to A it is completely visible, the outer side. From A to B, again from E to O it is the outer boundary, E to O. Again from B to O, again from B to O. Now let us rest this on the particular condition and see. So initially it was here, Now I am completely resting it on the slant edge. So for the observer, the base side is completely visible. All the sides of the base are completely visible. So what I can do is, I can take that particular portion, that is from E to D, it is completely visible. E to D, it is completely visible. And from D to C, it is completely visible. From D to C, it is completely visible. And again from C to B, all the sides are completely visible for the observer. Now let us apply the condition. The next condition, what we know is, the sides or the faces nearer to the observer are completely visible. Which are all the sides which are nearer to the observer? C dash to B dash, that we have done. C to B is completely visible. D to E, D to E is completely visible. Coming for the edges, that is from O to D dash and O dash to C dash is completely visible. So from O to D and from O to C, it is completely visible. O to C and O to D is completely visible. It is completely visible. Next, which is the side which is far for the observer? One is B dash of A dash and the other is O dash to A dash. Here O to B we have already done and O to E based on the first rule of condition, but O to A dash is of far from the observer, so it has to be the dotted line or the thin line, invisible line. We have applied the condition and we have successfully completed the second position. Now we are supposed to move for the next position, where they state that it was initially at this particular position, then we have rested on the slant edge. Now they are stating that the axis is inclined at an angle of 45 degree. There is a change in the axis length, where it indicates us to calculate the value of beta for the given condition. For that, what we are supposed to do? First we are supposed to draw the locus. Let us roughly draw a locus. And for the given angle, that is of 45 degree, let us draw a line. Let us draw a line of length, basically axis length, that is O dash of O1 dash initial. How much it is? 50 millimeter, such that we are going to obtain an locus point again. Now this is the new locus that we have obtained. This angle is of 45 degrees. This angle is of 45 degree. Now if I measure from O to O1, the axis length has been changed now. I need to measure from the O to O1 because the axis is inclined, and then cut an arc on the new locus that we have obtained. Now if I measure the angle of this particular inclination of the axis, I am going to obtain the angle of beta, and the beta that we have obtained after measuring is of 50 degrees. The beta that we have obtained is here, it is 50 degrees. Beta equals 50 degrees. Now we are supposed to not rest this at an angle of 45 degree. We are supposed to incline it an angle of 50 degree and complete the final position. So let us begin with the final position of the problem. So let us identify a point anywhere here. So let us identify a point, draw an line of which is inclined at an angle of 50 degree, so that we are supposed to transfer entire second position on that particular line. So how to do that? Again, we are supposed to follow the very known method, which is an arc method. So identify any O point first, identify the point of O. So this becomes our reference. This become our reference for us in order to transfer completely. Now O and A are on the same line, so measure it and cut an arc. Measure it and cut an arc. So this is my point A. This is my point A. Now let us transfer all other points, and be careful that once if you measure one of the length, that will be same on the other side also. Like if you measure from O to E, O to B will be the same length. So O to E, I am going to measure O to E, which is same from O to B also. So this is my point O. I am start transferring the points O to A and O to B, and measure from A to E, complete the point E, and similarly from here. So now I have transferred successfully the point of B and E. I have transferred successfully the point of B and E. What is the next thing that I am supposed to transfer? I am supposed to transfer O to C and O to D. So measure from O to D, measure from O to D and cut an arc. Measure from O to D and cut an arc. Similarly, the other point, that is the point C. In order to complete it, measure from O to D, A to D, A to D. Similarly, it will be same from for the point C also. Now I have successfully transferred the point of C and D. The only thing that is left out is of O1, which is along the same line of O and A. Measure the distance and cut an arc. Measure the distance and cut an arc. So I have transferred all the points of the second position to the final position. So let us complete the process. Let us complete the process. Let us join the points. We know that D to C is a thick line. Similarly, D to E and C to B, and from B to A to E, D to C, it is a thick line. Similarly, C to D is a thick line. Again from point E also it is completely visible. Again from point B, which is the outer boundary, and I have a thin line from O to A. Now I have successfully transferred all the points for the beta angle that we have obtained, that is for 50 degree, that is for 50 degrees. Now let us complete the final position by drawing the projection lines from the respective points. So to begin with, let us begin with from the point O itself. So the O and O dash are on the XY line. So I have drawn the projection lines. Again from the point of E, from the point of E I am supposed to draw the projection line. From the point of A, supposed to draw the projection line. From the point of D, supposed to draw the projection line. From B to C I am supposed to draw the projection line, which comes along the same line basically. Now let us draw the projection lines from the C dash D dash. Similarly from B dash of E dash. Similarly from B dash of E dash. Similarly from A dash, it's on the XY line, so you need not to worry. From O1 dash, we are supposed to draw a line, the projection line, in order to identify the O1 point. We have transferred all the projection lines from the respective points. Let us identify the points first and then complete the final position. So here we have E and the E dash. Similarly, I have A dash, B dash, and C dash, D dash, O dash, O1 dash. We have named all the points A, B, C, D and E dash. So let us apply the conditions and complete the final position. What is the first condition that we know? All the outer boundary edges are clearly visible. Faces or the edges are completely visible. So let us do that. From D dash to E dash and E dash to A dash is my boundary. Similarly from A dash to O dash, A dash to O dash, and here it is from D dash to C dash and from C dash to O dash. So the outer boundary edges are clearly visible. The first condition is satisfied. The other condition is such that I have placed my pentagonal initially here, then the slant edge resting, now for the inclination of 50 degree, and from the observer looks, he can clearly see the complete base. So we are supposed to connect all the base. So from C to B, it is completely visible. C to B, it is completely visible. That is from C dash to B dash. Similarly, from B dash to A dash also, it is completely visible. C dash to A dash to B dash also completely visible. Now, the other condition that we are supposed to apply, that the faces or the edges nearer to the observer are completely visible. So if I look from here, I can clearly see that the nearer sides are O dash, O to B, O to C. And if I check here, O dash to C dash and O dash to B dash has not been thick. So make that thick. Now are we done with this? No. Which is the sides or the faces which is far from the observer are not completely visible. We are supposed to represent that with the hidden lines. So which are those sides? So O to E and O to D, that is from O dash to D dash and O dash to E dash, we are supposed to represent that with a dotted line or the hidden line. Be careful while writing. The line appears to be overlapping, but no, it is not overlapping lines. Now are we done with all the sides? Yes, we are done with all the conditions that they are specified, but we have not represented the axis. So for that, indicate from O dash to O1 dash. So this concludes the problem on the condition what they have specified: a pentagonal pyramid of 25 millimeter sides of base and 50 millimeter in axis length rests on HP on one of its slant edges. Draw the projections of the pyramid when the axis is inclined at an angle of 45 degree. We have completed the conditions, or we have satisfied the conditions that they are specified in the problem. In the next session, let us take up another problem with respect to the different conditions and see how the projections could be drawn for the solids. Thank you.